I'll try to do a couple more examples. We'll do 2 more examples in this little video, so here's one more. Now let's do a negative bound. So let's calculate from negative infinity up to 0 of, say, e to the x dx. So again, so then we just go through the formal definition. So that's the limit as a goes to negative infinity of the integral from a to 0 of e to the x dx. And again, we'll just use the fundamental theorem of calculus inside of the limit. So we still have the limit here. It's going to negative infinity. And then by the fundamental theorem of calculus, we have to take an antiderivative of e to the x, but that is just e to the x. We evaluate at the endpoint, so the antiderivative is e to the x. We plug in 0, that gives us e to the 0. We subtract from that e to the a. And you should all know that e to the 0 is the number 1. That's the number 1. And so now we're taking the limit. So you're doing like e to the, we know that e to the negative 2, for example, intuitively, so you're going to do like e to like the negative 2, or e to the negative 10, or e to the negative 1,000, or e to the negative 1,000,000,000, because when we're taking the limit over here, the power is getting, well, it's negative, but it's getting very, very, very larger, and you should just remember from exponential notation that, like, for example, e to the negative 1,000 is 1 over e to the 1,000. So e to the 1,000 is a huge number, so 1 over that is a really, really tiny number. So when you take the limit, when you're actually taking the limit now, this thing will actually just go away as a goes to negative infinity. And so we're done, because that means when we take the limit, this e to the a part just goes away. And so all we're left with is the e to 0, which is just 1. So that is how that works. And let's do one more example where we integrate over the full number line. So from negative infinity to positive infinity of 1 over 1 plus x squared dx. So I'm going to just do that as, I'll split it up at 0. So let's say it's the integral from negative infinity up to 0 of 1 over 1 plus x squared dx, plus the integral from 0 on forever of 1 over 1 plus x squared dx. And then each of these two integrals requires taking a limit, so here we'd like to do the limit as a goes to negative infinity, integral from a to 0 of 1 over 1 plus x squared dx, plus, for the second integral, we'll take the limit as b goes to positive infinity, from 0 to b of 1 over 1 plus x squared dx. And both of these have the same antiderivative, and I mean they're clearly the same integral. Let me just make that a little bit clearer. So we're integrating this thing here, and we know that the antiderivative that we're looking for is inverse tan. So you should know that it's in a table of common antiderivatives. So we work inside the first limit, and by the fundamental theorem of calculus, this gives us tan inverse of 0 minus tan inverse of a, taking the limit as a goes to negative infinity, plus we're going to use the fundamental theorem for the second of calculus for the second integral, and that gives us, again, we still have the limit to deal with, but that gives us tan inverse of b minus tan inverse of 0. Cool. And now you want to know, like, what is tan inverse of 0? So you want to know, like, what angle has tangent is equal to 0. again, you're welcome to use a calculator, but like what is tan inverse of 0? We have both of those things. So tan inverse of 0, that's like saying what angle has tan of that equal to 0. We know that if you have 0 degrees, sine of 0 degrees is 0 degrees, and cosine of 0 degrees is 1, so tan would be 0 over 1. So this thing is actually 0, so both of these are 0. And then you want to know, like, when tangent is equal, what is tangent of negative infinity? And so here, when you take the limit, let's see here, let me do a different color. When you take the limit, this thing, when you take the limit, actually becomes negative 90 degrees. I'm going to write pi over 2, but that's the same as 90 degrees. And this limit over here, when you take the limit, gives you positive pi over 2, also known as 90 degrees. Again, you can just look at a graph to figure that out. But also ask me if you have any questions about why that is. Anyway, so when you're taking the limit, the red components go away, and all you're left with are coming from the blue components, but be careful, there's a negative there, so you get negative of negative pi over 2 plus pi over 2, and so that gives you pi over 2 plus pi over 2 is equal to pi. Anyways, so let's just have a look. So here's the example we're talking about. So again, in example 4, you're integrating from negative infinity to positive infinity. So formally, you just split it up. You go from negative infinity up to any point. I just pick 0 for convenience, and then you go from 0, negative infinity up to some point, and then from that point on to infinity. And then each of these integrals here, you do formally by taking the limit. So that's this next step here. Each one of these requires you to take a limit over a finite interval. And when you're doing these over the finite interval, you just use the fundamental theorem of calculus. And then you still have to take the limit, but when you take the limit, things cancel out nicely. Oops, excuse me. So